How's it going, everyone? In this video, I'll show you how to calculate the square root of a number without using a calculator. It's actually a very simple and elegant process. So, let's say we have the square root of 27. Well, first we ask, well, what's the square root of something close to this number that we know the answer to? Well, we know the square root of 25 is 5, and we know the square root of 36 is 6. And then we can conclude that the square root of 27 is somewhere in between 5 and 6, and probably closer to 5, because 27 is closer to 25 than it is to 36. So we can then conclude that 5 plus epsilon squared equals 27. Mathematicians use this symbol epsilon to refer to a small number that is greater than 0 but less than 1. And here we know that is the case because 5 plus something less than 1 is the answer we're looking for. If epsilon is equal to 1, well then we have 5 plus 1, which is 6, and 6 squared is 36. Okay? So, we then want to find what epsilon is. And we do that by expanding these brackets. So we have 5 plus epsilon times 5 plus epsilon equals 27. And as we expand these brackets, what we will get is 5 squared plus 5 epsilon plus 5 epsilon plus epsilon squared equals 27. And we can simplify this as follows, and then one more step. "25 can be brought over to the other side, so this becomes a plus 2. So we have 10 epsilon plus epsilon squared equals 2. Now, here's the most elegant part of this process. We know that epsilon is between 1 and 0. And if you square a number that's less than 1 and more than 0, you get an even smaller number. So epsilon squared here is approximately equal to 0, right? Epsilon is already a small number. Epsilon squared is an even smaller number. So if we're just looking for an approximation, rounding to some number of decimal points, we can actually cancel out epsilon squared. And we get that 10 epsilon is approximately equal to 2, which means epsilon is approximately equal to 2 over 10, or 1 over 5, or 0.2. Now remember what we started with. 5 plus epsilon squared equals 27. So 5 plus 0.2 squared equals 27, or 5.2 squared equals 27, from which we can conclude that the square root of 27 is approximately 5.2. Now, let's check that on a calculator. 27 square root, look at that. It rounds to exactly 5.2. So, there we have it. Now, what if we have to subtract epsilon instead of add it? Let's say we want to know what's the square root of 32. Okay, well, we know that the square root of 36 is 6. The square root of 25 is 5. So once again, the square root of 32 should be somewhere in there, but probably closer to 6 because 32 is closer to 36 than it is to 25. So what we have then is 6 minus epsilon squared equals 32. And then we go through the same process. Expanding these brackets gives us 6 squared minus 2 times 6 times epsilon plus epsilon squared equals 32. Simplifying, we have 36 minus 12 epsilon plus epsilon squared equals 32. Bringing the 36 over to the other side gives us a minus 4, and we cancel out epsilon squared because epsilon itself is already less than 1, greater than 0. Epsilon squared will be even closer to 0. So we cancel it out because it's approximately 0. So we have negative 12. Epsilon is approximately equal to negative 4. So epsilon is approximately equal to 4 over 12, or 1/3, or 0.33. So what do we conclude then? 6 minus 0.33 squared equals 32, or 5.67 squared equals 32. So the square root of 32 is approximately equal to 5.67. And if we plug that into our calculator, let's see what we get. So we have 32, square root it, we get 5.66 if we round that to 2 decimal places. So our approximation is 5.67. We get 5.66. Close enough, right? That's a pretty accurate estimate there, right? And if we go to 1 decimal point, well, it's exactly correct, right? So in general, if we want to look for the square root of some number, right, and there's some other value close to a for which we know the square root exactly, and we can conclude that r plus epsilon squared equals a, we can create a formula for finding exactly what r plus epsilon is, right? And here we don't know, are we adding something, are we subtracting something? So we'll actually define epsilon as being between -1 and 1. Okay? So expanding these brackets, we get r squared plus 2r epsilon plus epsilon squared equals a. 2r epsilon plus epsilon squared equals a minus r squared. And epsilon squared is approximately 0, so we cancel it out. And we then have r epsilon equals a minus r squared. Epsilon equals a minus r squared over 2r. We know what a is because That's the number we're looking for the square root of, right? And we know what r is because that's the square root of the number close to it, right? So for example, if a is 27, well then r is 5, which is the square root of 25, and in this case, epsilon would be positive. So once we know what epsilon is, we calculate r plus epsilon, and we get our answer. So the square root of a is r plus epsilon, which is r plus a minus r squared over 2r. And if we really want, we can create a common denominator here. Okay? So 2r squared over 2r plus a minus r squared over 2r equals 2r squared plus a minus r squared over 2r. 2r squared minus r squared is just r squared. So this simplifies to r squared plus a over 2r. That is a square root of a, where r squared is a square number close to a. R is the root of that number. So for example, we want the square root of 27. Well, that's going to equal to 25 plus 27 divided by 2 times 5. 25 plus 27 is 52, and we divide that by 10, and we get 5.2, which is exactly the answer that we got before. Okay, now what if we want the square root of 32? Well, that would be 36 plus 32 divided by 2 times 6. So 36 plus 32 is 68 divided by 12. That gives us 5.67, which is exactly what we got in our approximation. So I hope you enjoyed that, and until next time.